take down a problem. An infinitely long wire is bent into the shape as shown in the figure. Is bent into the shape as shown in the figure. A current is passed through it as shown. Pass through it as shown. Calculate the magnetic field at the center C of circular loop. First take down the figure. This is the given figure. And radius is also given r. An infinitely long wire is bent into the shape as shown in the figure. A current is passed through it as shown. Here in the loop it flows in the anti-clockwise direction. So actually the infinitely long wire is bent like this. Calculate the magnetic field at the center C of the circular loop. Now the magnetic field here at the center is due to two things. One is the field is produced due to the current in the circular loop. Another one is field is also produced due to this long straight wire. We need to calculate first due to the field due to the circular loop, also the field due to the straight wire. Then we have to add them vectorially depending upon their direction. Now we have learnt how to find out the magnitude of the magnetic field at the center of a circular loop, and also we know how to find the magnitude of a magnetic field of a straight wire at a distance r from it. We will find one by one and then we will add them or subtract depending upon the direction. If they are in the same direction, we have to add them, or I can say we have to add them vectorially. So you write like this: magnetic field is produced at center C due to long straight wire and circular loop. Magnetic field is produced at the center C due to straight wire and circular loop. Straight wire and circular loop. Now first we will write what is the magnetic field due to this straight wire. Magnetic field at the center due to straight wire is magnetic field at the center due to straight wire, due to long wire. is, we know the formula, B1 equal to mu naught by 4 pi mu naught by 4 pi into 2I by r, because we are finding at a distance r from the conductor. Now you apply the right hand grip load to find out the direction. If you do that at the center, you will get the direction which is, you know, coming out of the plane of the paper, or I can say it is directed outwards, or it is represented by dot. Directed outward. Direction is important because finally we need to add them or subtract them depending upon the direction. Directed outwards. Now next is magnetic field at the center due to the circular loop. For a circular current carrying loop, the field at the center, we know how to calculate. It is mu naught I by 2r. Mu naught I by 2r. And what about its direction? We know because it is anticlockwise direction. At the center, again it is directed outward. Or coming out of the plane of the paper. Now find out the total magnetic field at the center. Is B1 plus B2, that is vector addition. So we can write it as equal to B net. Net field at the center, B net, B suffix net, net field at the center as B1 plus B2. We can just add them because both are in the same direction. Both are directed outwards. Add these two, B1 and B2. We get mu naught by 4 pi mu naught by 4 pi into 2I by r plus mu naught into I divided by 2r. Now try to simplify this. Here we have mu naught as common. Multiply the second term by 2 pi. Multiply and divide the numerator and denominator, multiply by 2 pi, so that we can take mu naught by 4 pi outside. I'll do that now. Mu naught by 4 pi into 2I by r plus mu naught into I divided by 2r, multiply and divide by 2 pi, so that the value of the second term does not change. Now what do we get? You take out mu naught by 4 pi outside. Mu naught 4 pi is common. Mu naught divided by 4 pi. Mu naught divided by 4 pi also, we know 2I by r is also common. Mu naught by 4 pi into 2I divided by r. If I take it out, the full term here, I'll get 1. On the second term, only the left out is pi. So this is the net field at the center. Mu naught by 4 pi into 2I by r into 1 plus pi. Or 2 will get cancelled. You can write it as mu naught by 2 pi also. Therefore, magnetic field at the center C is B net equal to mu naught into 2I 4 pi r into 1 plus pi, and this much Tesla. B net is mu naught into 2I divided by 4 pi r, mu naught into Ti divided by 4 pi r into 1 plus pi. That's magnetic field.